Okay. Okay. So good morning. So today we will continue with discussion number 3 on chapter 3 fluid static part 4. Okay. So this chapter is a bit long. Okay. So we have 4 parts. I have divided into 4 parts, and we have managed to cover over the course of more than 2 weeks. Okay, because we have cuti in between. So we have holidays. I think Jumaat ni pun cuti. So terpaksa macam cram. Okay, we need to a bit lari dari teaching plan, but it's okay. We try to finish on time. For chapter 3 part 4, so I've given you a puzzle assignment as well as a synchronous lecture in YouTube. So I hope you already listened. Okay, so it's very important for you to finish up the synchronous lecture before come to discussion. So that's why I give you some time for you to go through the video first and understand before come to discussion, so that when we discuss things, so normally I will give 6 questions, 6 to 7 questions inside that puzzle assignment, and during the discussion I will be discussing on that. Okay, so before we go to our discussion, I just want to quickly glance through chapter 3 part 4. Okay, so quickly on what are the things available in chapter 3 part 4. So we are still covering static fluid, so which is the stationary fluid, and chapter 3 part 4 is covering on buoyancy. Okay, ada satu term yang kita panggil as buoyancy. Okay, buoyancy dalam bahasa Melayu adalah daya apungan. Okay, so what makes you float? Okay, that is what we call as buoyancy or buoyancy effect. Okay, so that's what we are covering here. So quickly, I think it's a very short chapter. It's only 19 slides. Okay, so it's explaining what is buoyancy. So buoyancy is upward force inside the water. Okay, so if you want to put in a layman term, so whatever things that make you float inside the water, that is what we call as a buoyancy effect. Okay, so you can see here, buoyant force is caused by the increased pressure with depth in fluid. Okay, what is causing the buoyancy force? So we have known there's a pressure difference between the depth. Okay, dalam air, so lagi dalam lagi banyak pressure. So because of the pressure difference between one height to another height inside the water, so we have this buoyancy effect. Okay, so yang ni boleh tengok lah. So you have two force on top and also bottom. So in between you have a difference of height h. So because of that you are having a force. We call it as a buoyancy force. Okay, so yang ni kita pernah dengar Archimedes principle. So what is Archimedes principle? So the buoyant force acting on the body immersed in a fluid is equal to the weight of the fluid displaced. Okay, so kalau you ada satu body, so let's say this kotak, so this is 100 kg. So you put inside the water, so how much water comes out from the container? So that is associated with the buoyant force. Okay, so melalui itu, so that what we call as a Archimedes principle. So boleh go through lah description dia dekat sini. So I just going glance through. Okay, so buoyant force we always call as FB. Okay, not Facebook, FB. So force buoyant. So kalau you tengok FB ni, so you need to know that it is explaining about the buoyant force. Okay, so FB. So rho F is the density of the fluid, gravity and the volume. Okay, so buoyancy of floating bodies. Okay, so floating bodies, the weight of the entire body must be equal. So we will see a few situations later. Okay, so you have a part, the part yellow part is submerged inside the water and the red part is not submerged. Okay, so buoyant force is weight of displaced liquid. So when this weight is entering the water, so the rise in the water level. So kalau dia besar tu kita tak nampak lah. But if it's a small container, so kita boleh nampak. So when there's a weight entering the water, so you can see the water level will rise up. So that is what we associate with buoyant force. Okay, so 3 scenarios possible. Okay, when you put a body inside the water. Okay, one, so it will float. When it will float, when the density of the body is lesser than density of fluid. So automatically dia akan apung. Okay, so that's why siapa dekat sini tahu berenang? Siapa tahu float? Berenang itu lain lah. Okay, siapa tahu apung? Boleh. So kenapa you boleh apung? So what will happen kalau dalam air you jadi panik, then you minum banyak air. So indirectly you are increasing your density. Kalau density you lagi tinggi daripada density of the fluid, you akan tenggelam. So that's the principle. Kenapa body kita boleh apung? Sebab dalam tu ada cavity yang kosong inside the body. So your body is not solid. Kalau solid you memang akan tenggelam. Tapi our body is inside built like kapal. So inside the cavity is actually empty. So it is decreasing your body density. Then naturally you boleh float. You boleh float kalau you tak panik dalam air. So that's why when you are inside the water, you jadi panik. So try to jangan minum air. So kalau you minum air, automatically you akan jadi lagi panik, you akan drown. Okay, so that is the condition of the floating body. So how you want to suspend inside the water? Macam kapal selam. So kapal selam dia boleh buat tiga benda ni. Okay, so we are using these 3 principle, 3 scenarios. So kapal boleh float, kapal selam boleh float when it decrease the density of the body. Okay, of the submarine. Then it can float. So macam mana dia boleh suspend dalam air? So we call as a neutrally buoyant. So ada buoyancy force tapi dia manage. So dia boleh macam inside the water it can maintain. It's not going up, it's not going down. It can maintain. Okay, so you can suspend the body when you know what is the density of the water and you are controlling the density of the body. So you jadikan dia sama. Kalau density of your body and also density of the fluid is equal, you akan automatically apung dalam air. I think inside the not on the surface, inside. Okay, so you boleh. Sebab itu penyelam pun dia akan control berapa banyak water dia akan ambil. So kalau you are professional swimmer lah, so they will teach you how to inhale and exhale inside the water. Okay, then you can control this thing. Then sinking body meaning you tak buat apa-apa, automatically you sampai dekat dasar laut. So that happen when the density of your body is bigger than the fluid density. Okay, so 3 scenario lah. Okay, so application ship. So pernah terfikir tak kenapa kapal tu beberapa tan tapi still boleh apung? Okay, still boleh apung sebab dia macam body kita. So dalam kosong. So the body, so only the outer body is having weight. Tapi inside the density is much lower than the water density. Sebab itu dia boleh apung. So based on apa yang kita belajar hari ni lah, tadi 3 senario tu. Okay, so sebab dalam tu dia memang kosong. So you ada banyak udara lah dalam tu. Okay, and even though you stack up with so many things, still ship ni density dia kurang. Okay, so the engineers, they build the ship in such a way that it can float. Okay, so you boleh baca lah dekat sini. The steel, walaupun dia steel, still hollow inside. Dia kosong dekat dalam. Okay, so it makes the level of ship sink in the sea depends on the buoyant force that acts on it. Apa ni? Siapa pernah tengok gambar ni? So I think kalau you tengok dekat movie, so you always can see in the sailors selalu akan tengok benda ni. Okay, so this is actually water level. Okay, so different water level. So air tawar dia density dia lain, air laut density dia lain. So different water level. So these sailors, they have the knowledge of different water levels around the world. So itu dia pergi dari one continent to another continent, one country to another country using the ship path. So dia memang tahu, okay, dekat kawasan ni, so density of this water is this much. So I need to increase. So dia akan kawal. Dia dah pergi mana dah? Okay, so dia akan kawal benda ni. So they will monitor. So they will monitor the water level using this scale. Okay, kita panggil yang ni as a flimsole line. Okay, dekat sini boleh tengok lah water line. So biasa tengok tak, kenapa kapal ni dekat bawah dia ada warna hitam. So dia macam ada satu level. So that is actually indicating at which level the ship must be travel. So dia ni macam untuk kawal lah. So selalunya the ship will be maintained at this level. So level ni adalah kawal by this device. So we call as a flimsole line, and it's controlled by this. So the flimsole line is painted on ships to show the depth of ship should travel at. So dari luar kita boleh tahu lah. So if the water level is already reached here, so meaning there's something wrong with the sailor. Dia tak pandai baca. Tak pandai apa. So the possibility of your ship to sink is very much higher. Kalau water dah sampai dekat sini, nanti jadi macam Titanic. So Titanic. Okay, so water level is already reached top. Okay, so another application is submarine. So submarine, you boleh baca lah dekat sini. I think you have a lot of explanation. So I just want to show you. So this is the deck di dalam submarine. So submarine, I think kita biasa tengok ada water line. Then you have a deck. Deck adalah tempat all your military ke. So dia akan ada dekat dalam lah. So all your navy force. Okay. So dekat bawah ni dia ada ballast tank. So ballast tank is the place where you take in water and you put out water. So take out water. So kalau ballast tank ni dia penuh dengan air, what will happen? So it will increase the density of the ship and it will start to sink. So kalau ada air lah. So if you want it to float back, so just keluarkan air dari sini. So keluarkan air dari sini, automatically the density will reduce and it will automatically float. Okay, so the person who operate the submarine must have the knowledge. So how much water to take in and how much water to take out. So based on that, sebab tu you boleh tengok submarine dia boleh pergi ke atas permukaan, and it also can go deep inside the water. So is by controlling the density. Okay, so density of the sea you cannot control, can? You only can control the density inside the body. Okay, so that is another application. Okay, so earlier we have seen the buoyant force inside the water. So how about buoyant force by air? Okay, apa application yang selalu you boleh ingat? Buoyant force. Yeah, I think ada dalam soalan lah. Okay, hot air balloon. Okay, so pergi ke Turkey memang nampak. So everywhere got hot air balloon. So you are controlling the buoyant force. Okay, so buoyant force is created by the warm air. Sebab tu you tengok dekat balon udara panas, tengah-tengah tu dia ada something to heat up. So ada api kan. So api tu akan make the surrounding dalam balon tu udara dalam balon tu untuk jadi panas. So waktu jadi panas, so it will cause a buoyant force. Buoyant force macam dalam air, buoyant force dia akan mai dari bawah. Udara dari atas. So it will push. Okay, but you need to know that because of the density of air is very less, much lesser than 1,000 times lesser than water. So the buoyant force is very small. So you need to generate more force in order to create more buoyant force. Sebab tu balon udara panas pun dia boleh apung, dia boleh move. Similar like submarine, it can move from one place to another place. Okay, so this is some calculation. Okay, bahagian part ni ada calculation. So if you see, you have two scenarios. So you have a concrete block, okay, and it's tied with the rope. Okay, so yang ni something yang you belajar dalam applied mechanics. Okay, so you have tension because on the rope, and you have a weight of the body because of gravity, and this is on the air. Okay, dekat udara dia lain, and dalam air dia lain. So dalam air, so you boleh tengok dekat udara cuma ada the tension from the force from the tension on the rope and also weight. Tapi dalam air, so you have additional FB, the buoyant force, which is pushing, and the direction is dari bawah ke atas. Sebab dari bawah lagi banyak pressure compare dengan yang atas. So that's why it created a buoyant force. So inside the water, you need to take into consideration tiga force. One is the force of the rope, okay, tension, the weight, and also the buoyant force. Okay, so boleh tengoklah solution. So macam mana nak calculate. So I think you can go through here. So apa yang important, okay, benda ni. So you need to take, so same direction you tambah, different direction you put at the sides. Okay, sebab tu you dapat equation ni. Then you boleh tengok in the air is 10.8 Newton. Okay, the tension. Tapi dalam air, because buoyancy force dia tolong, so your force on the rope is reduced to 6. So you boleh go through lah. Yang ini explanation I dah explain dalam video. Okay, so another example. Okay, similar. So you have two bodies suspended. So you need to find the tension on the cable and also the mass of this object. Okay, so it's given is a water. So you boleh tahu lah the density of water. So temperature is not so required, and you can see so how much it is submerged in the water. So I dah bagi dah dari mana you dapat. Okay, so based on the same principle, so when you first get the question, convert ke free body diagram, baru you nampak. Okay, so macam dekat gambar ni you tak nampak sebab you pun tak tahu force, what are the force acting. So when you draw like this, so you divide it into two. So dia ada dua bahagian. So the first bahagian, so dia ada buoyancy force acting from down, so the direction is upward, and downward adalah tension and also the weight. Okay, and here you have two side. So you dah pecah macam ni, baru you buat calculation. Okay, so you buat calculation, at the end you boleh cari the mass. Okay, the mass of the this body. Okay, so another example. Okay, similar. Okay, I just discuss briefly on the important side. Okay, so dekat sini, okay, so that's two assumption. Satu adalah dia nak cari the magnitude and direction of the force required to hold the cube in equilibrium completely submerged. So maksudnya dalam air dia apung. So it's not on the surface, dalam air. So you need to either apply force. Okay, kalau body tu dia density dia kurang, you need to apply force to make it maintain inside the water. Ataupun kalau density dia lagi tinggi, so you kena tarik dia untuk maintain dalam water. So this thing you don't know whether it's upward or downward. So you ambil dua-dua scenario. One, you assume that the cube will sink naturally. So you need to have a force to pull it to maintain. So another thing, they assume the cube will float. So you can apply a force to make it maintain inside the water. So you ada dua scenario. So based on that you have two set of equation. So Fe is needed to avoid the cube from sinking, and Fe is needed to avoid the cube from floating. So ada dua situation. Then you buat calculation lah accordingly. Then one side you boleh tengok dia dapat negative 5.74, and one more side you dapat positive 5.74. So force cannot be negative. So based on this you tahu, so this scenario yang is happen. This is what it happened. So the direction of the force should be downward. So meaning so this situation yang betul lah based on the calculation. So you are applying a force to make it maintain inside the water. Okay, so both solution yield the same numerical value. Dua-dua pun 5.74, but they have opposite sign. Satu negatif, satu lagi positif. So the negative sign for the solution of the left means the same direction of Fe in the case of cube sink was wrong. Maksudnya yang ini dia salah lah. Okay, so therefore both approaches give the same result. Okay, yang ini bukan assignment lah. So this one you try yourself. So no need to send. So yang ini I think I gave last time. Okay, for the students saya lupa nak ubah. So you just try yourself. Okay, I already gave the answer. So try to do until you get the answer. Okay, the value of D for case A, and also case B. Okay, so try to do. Okay, so this is what practically covered in chapter 3 part 4. Okay, so you have 6 questions that is covered. Okay, we will quickly go through 6 soalan yang ada dalam Edpuzzle. Okay, so along the way I think I already explained briefly what was in the lecture note. Okay, so first question. So comparing two person with different weight, person A with weight 100 Newton and person B with weight 200 Newton, who will experience greater buoyant force if jump into the water? Siapa? So ya, ada dua orang. Okay, so person A 100 Newton, tak possible lah 10 kg kan. Tapi tak apalah, assume is 100 kg and 200 kg. Itu pun tak possible juga, tapi tak apalah. So better than 10 kg kan. Okay, so you campak dua-dua dalam air. Okay, so that day also I was saying, so when you dive, so kalau you dive, you are entering the water at an angle. So it will reduce the drift. Kita panggil as a drift lah. So dia maksudnya dia akan jadi smooth. Tapi kalau you enter water from on top, so I think you tengok kan Pandalela Renong. Dia akan tengok, dia jump dari atas. So dia akan tengok berapa banyak water disperse. So you need to know, you as a professional diver, so you need to know macam mana nak kurangkan percikan air. So kalau jangan you jump, boom. Jangan. Jadi macam saya tak tahu lah nak cakap apa kan. So jangan macam tu. So percikan air tu must be control. Okay, so that's why you tengok yang dive ni dia selalunya badan dia is how to say macam aerodynamic lah. slim, aerodynamic. So you need to reduce the water dispersion. Okay, so dalam case ni, person A ke person B will experience more buoyant force. Kenapa? Sebab dia lagi berat. So I dah bagi tahu hari tu. So lagi berat. So so when you put 200 Newton of force, water akan generate equally opposite force untuk tolak dia. Okay. So in this case, so 100 Newton and 200 Newton. So 100 Newton dia punya weight adalah kurang. Okay. So weight dia kurang. So when you enter inside the water, so buoyant force yang acting on the opposite direction pun akan kurang. Okay. So that's the thing lah. Sebab dia, kalau dia berat, dia takkan pergi dalam sangat. Okay, naturally kan. So kalau dia terjun dalam air, dia naturally they won't go too in deep as their own lah, as naturally. Kalau dia ada skill untuk dive tu dia lain. Tapi kalau dia tak ada skill, dia just jump macam tu, dalam air kan, buat macam boom, terjun kan. So biasa kan, selalu kita pergi ke sungai ke air terjun, so you jump like that. Okay, so for this case, so the one that will experience greater force is the person B with 200 Newton because of the body weight. Okay, so the body weight will create more buoyant force inside the water. Okay, as I said, so you need to know, you need to keep on asking why. Kenapa person tu more force? Because of the body weight. Okay, because of the body weight. Okay, so that's for the first question. Okay, second question. Based on your understanding, how buoyant force can help you to float? Okay, kalau you nak explain in an engineering term. Okay, how you want to explain? Okay, how buoyant force can help you to float? Yeah? So anyone? Panggil nama lah senang. Kita panggil dari belakang pula. Presley, ada? Ya. Yeah. Saya explain. Dalam bahasa Melayu pun tak apa. Just explain what you know. Okay. So which one must be higher for you to float? So body density must be higher than higher or lower? Lower. Okay, your body density must be lower than density of water. Then you automatically will float. Okay, thank you. Okay, tepuk tangan. Okay, good try. Okay, so if you want to float, okay, macam I bagi tahu in real life, siapa takut tenggelam? Takut tenggelam. So one tips, if you want to avoid yourself from sinking, jangan panic. So and don't drink water. Kalau jadi panik and minum air dalam laut ataupun sungai, you automatically akan float, because based on principle yang kita belajar hari ni, so you will increase the density of your body. Kalau your density is higher than the density of fluid, you automatically akan tenggelam. You nak berenang pun tak boleh. Okay, so don't drink water. So that's the key point lah, point of survival. Okay, especially if you don't know how to swim, tapi you nak swim. Okay, so that's one thing. Okay, so that's for the second question. Third question. Explain how the flimsole line can be used in a ship. Ini adalah flimsole line. So kalau you tak tahu apa yang maksud dia, okay, I think normally this one sailors know, and if you are a marine engineer, you akan tahu. Okay, but this is the description. So TF, tropical freshwater. Okay, tropical freshwater dekat mana? tropical. So kita baca dulu. So TF is tropical freshwater, F is freshwater, T is tropical freshwater. Kenapa ada dua? Okay. So T pun dia ada dua kot. I think maybe different densities. Okay, tropical freshwater but having two different density. Then you have salt water in summer. Okay, salt water in winter. Winter in North Atlantic and Lloyd's register. So yang ni tak berapa pastilah, tapi yang lain ni is different parts of the world. Okay, different parts of the world have. So normally the world is covered by salt water in summer. Okay, salt water in summer maksudnya dekat sini lah. So inside the panel ataupun tempat yang the sailor is, kan you pernah tengok kan ada benda bulat tu, so they will pushing to move the ship, navigate the ship. So you can see this thing, and normally we will pass through the salt water in summer. Sebab most of the part, so kita panggil as 1040 window. So 1040 window yang dekat Khatulistiwa. Khatulistiwa adalah kosong. So 40 degrees above and 10 degrees below. So meaning the middle part of the world map is covered by salt water in summer. Sebab dia dekat dengan Khatulistiwa. So kita tak ada macam perubahan musim. Okay, we don't have 4 seasons. Okay, but if we are going through the northern side, okay, northern side ataupun dekat kawasan dekat Australia ataupun dekat Europe, so you normally can also face macam salt water in winter. Okay, depends on the season lah. Okay, depends on the season. Okay, and yang ni North Atlantic. Atlantic ke atas ke bawah? Kutub utara ke kutub bawah? Kutub selatan? Utara, Atlantic. Arctic dengan Atlantic. So ada dua kan? So cari tengok. So kat mana North Atlantic? North Atlantic kalau you nak pergi above or below the kutub lah. Okay, you want to move. Tapi dekat sana you need to understand the sailors, they will avoid that part. Kenapa? So dia kutub, so the magnetic reaction dekat sana is very high. So because of that, ombak akan the tide will be very big. So kalau you lalu kawasan tu, so kapal you akan dia akan jadi macam ni lah. So the possibility of it to terbalik is very high. Okay, so it's very high. So normally the sailors they ada map macam Waze kan. Kita gunakan Waze on the road. So they have like Waze on the sea. Dia akan lalu the particular part. Dia takkan pergi, sebab itu you boleh tengok kapal akan lalu one particular part. Dia takkan lalu semua, dia takkan lalu semua laut. Dia takkan jadi macam aeroplane. Aeroplane kalau you tengok, they will cross whichever place they want, as long ada airspace. Kecuali Bermuda Triangle lah. Bermuda Triangle ada misteri kan, kapal hilang. So they won't go through that. But for sea, you cannot go through all the part. Dia ada part dia sendiri yang kapal kena lalu. Okay, so so explain how the Flintstone line can be used in the ship. Macam mana? So based on apa yang you nampak dekat sini. Yang ini adalah left and right, so meaning the ship. So selalunya dia kena stable lah. Kalau kapal you sengit, yang ni dia akan turun bawah, yang ni maybe naik atas. Okay, yang ni turun bawah, naik atas. Then what will happen? Okay. Oh, ada bunyi. Ada entertainment. Okay, so what will happen kalau yang ni dia sengit? Kalau dia yang scale ni sengit, what will happen? Apa dia bagi tahu? So maybe there's a possibility of hole. Okay, sebab tu air masuk maybe at the one side and it makes that particular side to become heavy. Jadi kalau kejap tak apa. Meaning maybe because of the wave or what, so the ship is like moving. But tapi if it's prolonged, then you need to do something. If not, possibility of the ship to sink is very high. Okay, and this is the level that you need to maintain. Okay, so this scale will be maintained with the flimsole line on the ship. Dekat ship ada line kan. So the sailor will try to maintain the ship according to the line and also according to the water density. Okay, so these are the water densities. So kalau you nak tahu more on detail, so you maybe can try to check lah. So what is tropical, what is TF, what is T, what's the difference? So what is Lloyd's register? So you boleh cari tengok. Okay, that's on the third question. Okay, fourth question. Okay, based on your understanding, what will happen if there is a leakage A in the submarine body and B in the ballast tank? So tadi kita tengok ada dua bahagian kan. One is the deck and one more is the ballast tank. Ballast tank is the place where you take in water or take out water. Okay, in order to float or sink the submarine. So ada dua situation. Yang ni based on your understanding lah. What will happen kalau submarine body, meaning dekat deck ada lubang? So what will happen? Kapal tu akan tenggelam ke akan float? So yang ni natural lah sebab dekat body. So tapi you need to explain, jangan cakap tenggelam atau it will sink or float. So you need to explain why. So what is the principle behind that? Okay, so principle behind buoyancy force is the density. Okay, density. So dia akan main dengan density. Okay, so in this case untuk A, how you will explain? So kalau ada lubang, so what will happen to the density of the body? So you can explain. So the water will enter. So water will enter because of the pressure outside will be higher than inside. So water will come inside. Dia takkan keluar dari dalam, dia takkan pergi luar. Sebab dia akan follow upstream to downstream. So dekat luar dia pressure dia lagi tinggi. So water will come inside. So when the water come inside, it will fill the empty space and it will increase the overall density of the submarine, and the submarine will start to sink because the density of the submarine will be higher than density of the water. Okay, so that's the first answer. Okay, second answer, in the ballast tank. Kalau ballast tank, what will happen? Ballast tank dekat bawah lah. So it naturally take in water and is take out water, and is not really connected to the body of the submarine. So what will happen? Kalau ada leakage dekat ballast tank, ya? Siapa? Saya dengar semua pakai mask, saya pun tak tahu siapa cakap. Boleh, yang ni based on understanding je. Soalan-soalan macam ni lah akan keluar dekat exam, which make you think. Panggil nama Syarul Azlan. Ada? Siapa Syarul Azlan? Siapa Syarul Azlan? Tak ada? Tak ada Syarul Azlan? Macam ada je. Tak ada? Nanti saya panggil nama, ada, saya kira tak ada. Sufyan Davis, tak ada. Tan Yu Chen, tak ada. Tan Yu Chen. Oh, susah nak admit dah. It's okay, just try. So what will happen? The second scenario. So there's a hole in the ballast tank. Ballast tank dekat bawah. The place where you take the water. It will sink or float? Sink. Why? So with me must I explain why? Understanding only. It's okay. Right or wrong is a different case. I will explain why. So it's a tricky question kan? If, okay, so I try to help you. If there's a hole, so what will happen to the water? Will it come in or go out? Dia akan keluar ke dia akan masuk? Ya, keluar ke masuk? Masuk. Kenapa? So, kena answer lah kenapa kan? So, okay, similar. Okay, thank you. Okay, tak apa, tepuk tangan dia try. Okay, thank you. Okay, so if there's a hole, maybe I look case lah. Okay, so you have two places. One is the deck where your Navy force will be there, and one more is the ballast tank. So ballast tank, if this is filled with water, what will happen? Submarine will sink sebab density akan tinggi. So kalau tak ada air, dia akan float. Okay, so the question earlier, ada lubang dekat sini. Okay, so let's say there's a hole here. Sorry, not here. Ini body kan, boleh lah. So dekat sini dengan dekat sini. Okay, so you say the pressure here is more than pressure inside the deck, kan? So water akan masuk. So kalau ada lubang dekat sini, so pressure ada dekat mana? So the pressure here and pressure in the ballast tank, which one will be higher? Kat luar. So it's still higher. So the water will go in, kan? So kalau water go in, betul lah kawan ni bagi tahu, it will sink. Kenapa? Sebab kawasan ni akan penuh dengan air. So the submarine will automatically sink. Okay, faham? So dua-dua situation pun the submarine will sink. Okay, because the density of the submarine will be increased by the water density. Okay, so water masuk dia akan jadi lagi tinggi. Okay, so this kind of tricky questions can be asked. Okay, so please you need to understand. So kalau you nak, benda dia simple je. Tapi since this a different part, so you pun jadi confused. Dia akan float ke dia akan tenggelam? So you go back to the principle of the water. So where the water will travel and where the density will be increased or decreased. Okay, number 5. Okay, for your opinion, what will happen to a hot air balloon in the sky if there's a hole in the balloon? Ni. Tiba-tiba shock terbang, tiba-tiba ada lubang. Burung main attack. Burung tak ada waist, dia terus langgar. Ataupun dia follow the waist, dia tak nak deviate. Terus langgar, dia nak pass by sebelah sini. What will happen? Tadi dalam air. So yang ni? Ya? Jatuh ke? Atau dia akan naik atas? Kalau naik atas, mampu lah. Macam mana pun akan mati juga kan? Okay, so yang ni pun sama. Okay, so when there's a abnormality in the body, okay, sebab yang ni pun dia gunakan buoyant principle. Okay, buoyant principle you nak apungkan, so based on the density difference. Okay, so macam mana balon udara panas akan apung? Okay, for your opinion, yang ni pun for your opinion. So betul atau salah, that's different case. Okay, first thing you need to understand macam mana balon udara panas ni dia boleh apung. Sebelum you tahu macam mana dia akan turun ke naik. So first, how this hot air balloon dia akan naik. Okay, so dalam ni ada udara. Okay, udara, so maybe it can be helium, so some gas which is light. Okay, helium dekat surface dia tak berat, dia still light. But if you panaskan dekat bawah ni, dia ada pemanas kan. Normally you can see dia akan panaskan. So they will eat up the helium inside. So dia panaskan balloon ni, dia akan jadi panas lah. So what will happen to the molecule of helium inside? Kalau dipanaskan, it will start to move secara rawak. So random movement. So it will start to push this balloon at the surface. Dia akan tolak dekat surface. So balloon ni pun dia jadi besar. Then after some time, because it warm, dia akan push sampai balloon ini boleh apung. Because the density of the helium molecule or the helium gas inside will be lesser. Dia akan jadi kurang. Dia akan jadi kurang than the udara dekat surrounding. Then when yang ni jadi kurang, dia akan apung. So it will go up lah. So dekat sini you boleh monitor. So you boleh monitor macam mana dia nak gerak. So dia akan ada propeller, okay, to move. Then what will happen when there's a hole? So udara dekat luar jadi density tinggi ke dekat dalam? Okay, based on case. Dalam ke luar? Ya? Yeah? So kalau luar, yang ni dekat dalam ni dia kurang daripada yang luar, dia akan apung. Kalau ada lubang, udara dari luar akan masuk. So what will happen? Dekat dalam apa akan jadi? Udara yang density tinggi dari luar akan masuk ke dalam. So dalam ni dia akan jadi density tinggi compare dengan yang kat luar. So automatically dia akan turun. Ataupun dia akan jadi sama lah dengan yang kat luar. So no difference. So it will go back to, because of gravity dia akan jatuh. Faham? So dekat exam explain macam saya explain, baru dapat 5 markah. So kalau dia cakap dia akan terjun ataupun dia akan pergi ke atas, you takkan dapat markah because you didn't explain why. Okay, faham? Okay, last question. Okay, we have seen the forces and pressure under water and the air. For your opinion, how can be the forces and pressure in the space? Tadi tengok dalam air, dekat udara dah tengok. Okay, outer space macam mana? Outer space. Yeah? No pressure. Okay? So how can be the forces and pressure in the space? So kalau you tengok, yang ni kita dekat sea level, so 101 kilopascal. So 10 km dia kurang 26, 5, 1, 0.3. So 100 km is 0. Negligible. So rasanya outer space ni more than 100 km tak? More than 100 km tak outer space ni? So consider because tak ada gravity dekat outer space, no pressure. So when there is no pressure, no force, because F equals to PA. So if pressure is 0, then the force also becomes 0. So dekat outer space you akan automatically apung, because no pressure and no force and no gravity. Okay, so you can see, for your opinion, how can be the force and pressure in the space? So no force, no pressure. So automatically you will float. Okay. Okay, so any question? Chapter 3, part 4. Okay, so kalau tak ada, I will continue to take attendance. So take 5. Then we will continue with chapter 4. Okay, Arif Syairan, Ahmad Firdaus, Ajwad Fatih, Danny, Ku Musfira, Muizin, Muhammad Amar, tak ada. Muhammad Faiz, tak ada. Muhammad Faris, tak ada. Muhammad Firdaus Khairozi, Muhammad Firdaus Farid, Muhammad Farid, tak ada. Muhammad Firdaus Romi, Muhammad Aziz Aikal, Ilham Amir, Khairul Azhar, Muhammad Nabil, tak ada. Wafi Hakim, tak ada juga. Zahirul Hakim, Nisa Akila, Nur Alia, Nur Aimi Nadira, Nur Ain Najwa, Nur Aisyah Amira, Nur Dini, ada. Nur Fakira, Nur Afizatu, Nur Uwayina, Nurul Alia, Nurul Aura, Nurul Farain, Nurul Shakira, Parameswaran, Premitra, Pritika, Presley, Sharmila, Syahid Azimi, Syarul Azlan, Siti Nurliana, Stephen Lee, Sufyan Davis, Syarul Anwar, Tan Yo Chen, Tilagan, tak ada. Tiwaga, Umar Razin, Ungku Arman Shah, Wan Muhammad Irwan Amfif, Wan Nur Kamarina, Yap Kalop, Zamir Uzairi, Zarik Iskandar. Okay, so I tengok ada few names yang I consider macam tak adil dan akan dapat surat amaran lah. Muhammad Firdaus, Muhammad Farid. Okay, yang ni saya akan call the parents . Okay, siapa? Muhammad Firdaus, Muhammad Farid. Ada apa-apa isu ke? So, I tak dapat apa-apa surat. Okay, so satu nama adalah Muhammad Firdaus, Muhammad Farid. Parameswaran. Dan ni pun saya akan call parent. Syahid Azimi. Dan ni pun saya akan call parent. Ada few potential lepas ni. Okay. Nanti kalau yang tu adalah kawan-kawan you, tolong kontak saya lah. Sebab I nak minta nombor parent. Tapi dalam sistem pun ada. Saya boleh je call. Okay, tolong off. Sorry.